Hi. This is Algebra 2, 9-4, identifying conic sections. I'm just going to go over a little bit of review of stuff we covered a couple weeks ago, well before the break. And then there is a little assignment on Pearson online for you guys to look at. But most of it's just going to be a review of stuff we've already looked at. So that will be helpful if you haven't looked at the review that I posted on Pearson. I have this little piece of paper. Has all the different conic sections. They're um, standard form equations for the parabolas, the circle, the ellipses, and the hyperbolas. This is posted on Canvas if you would like to use it as a reference. So I will reference these as I'm working today on the couple of examples I have for you. Also, because I'm at home and I'm not in my classroom, I have this tiny little whiteboard that I'm hoping will work out just fine. I might have to go find a bigger one at the store if this doesn't work so well. So just okay. This is all I've got. So identifying conic sections. You're going to classify this section as either they're going to give you an equation. It will not be in standard form. So the ones that I just showed you were all standard form. The equation they're going to give you will not be standard form. And then you have to figure out how, whether it is a parabola, a circle, an ellipse, or an hyperbola. So if I have this equation, feel free to, I think there should be a way for you to chat and ask me questions if you have them. So let me know if you have questions. Okay, so this is what the equation they're giving me looks like. And then I decide which one it is. And I'm going to go ahead and put it in standard form today for you. It doesn't require you to do that on your assignment on Pearson. So just know that that's not part of the question. They're just asking you to decide which one it is. So what I'm going to do is I'm going to move the 9 to the other side of the equation. Then I'm going to group together the x stuff and the y stuff and complete both of the squares, complete the square on each of those. So if I put x squared plus 4x and then leave a space, and then y squared minus 6y and then leave a space, and then the 9 would be on the right-hand side now, right? And it would be a negative 9. So then I decide what number goes in the space that completes the square. And remember, we talked about the middle number, half of it, and then square that number. So half of 4 is 2. 2 squared is 4. That's not what I wanted to do. It's like this. So I'm going to add a 4 right here. I'm going to add that 4 over to the right-hand side. And then half of negative 6 is negative 3. And then negative 3 squared is 9. So I'll add 9 there. And so, sorry, that's a 9 right there. It's hard to see. Okay, so then on this side, x plus 4 makes x plus 2 squared. And then y minus 6y plus 9 makes y minus 3 squared equal to 4. And so this is a circle. And its center is at negative 2, 3. And its radius is the square root of 4, which is 2. So could you have identified that it was a circle before we did all the completing the square and rewriting it into standard form? How do you know it's a circle before you do all of that? It has an x squared and a y squared, so that makes it either a circle, an ellipse, or a hyperbola. You're going to see in a minute when we look at ellipses and hyperbola, they have coefficients in front of the x squared and in front of the y squared, whereas a circle does not have coefficients. We won't end up dividing anything, which we will for the ellipses and hyperbolas. So that one is a circle. And then I'll go ahead and do another example in just a second. Okay. I'm going to erase the title at the top. Just give me a little bit more room. This is my little handkerchief eraser because the eraser that came with this was useless. Okay. Okay, so you might be able to identify this one as a parabola without even doing any of the work to get it into standard form. I'm going to go through the work to get it into standard form just as a review for you, and then we'll look at how to make the graph of it as well. The how I know that it's a parabola and not an ellipse or a hyperbola or a circle is ellipses, hyperbolas, and circles all have x squared and y squared. This one just has a y squared, does not have an x squared. So I'm going to add the x to both sides, add the 2 to both sides, and then I'm going to take the 4y squared 8y, and I'm going to factor out the 4 that's there. So it's going to look like this. And then I'm going to, like on the last problem, decide what number completes the square. So half of 2 is 1, and then 1 squared is 1. So if I add 1 right there to complete the square, I have to add the same amount to the right-hand side of the equation. Now, on the left-hand side of the equation, that's not actually a 1, right? Hang on, let me do this a little bit. No? Okay. That's not actually a 1. That's a 4 times 1, right? So 4 times 1 is 4, which means to the right-hand side of the equation, I would be actually adding a 4. So now on the left side, I have 4, and then y plus 1 squared equal to x plus 6. And then subtracting the 6 from both sides. That is my standard form equation for a horizontal parabola. I know it's horizontal because it's x equals y squared. That means that the parabola either opens to the right or opens to the left. And since the 4 in front of our parabola is positive, I know it opens to the right. And so then we identify the focus, the directrix, the vertex, and so on. The vertex, the 6 is shifting the graph to the right 6, and the plus 1 is shifting the graph down 1 to the right 6. To the left 6. Sorry, to the left 6. So the vertex is at -6, -1, and it opens right. Sorry about that. So there's the vertex, and it opens to the right. So it's going to go this way. So the next thing we would find is our focus and our directrix. So we know that 1 over 4c is the value that's in front, our a value, and sometimes it's the number that's multiplied in front of our parentheses there. And so if we just solve for c, we get 1/16. So I would multiply the 4c or the c to both sides and then divide by 4, giving me 1/16. Oh, my dogs are barking. Sorry about that. Super annoying. That means that our focus and our directrix is going to be 1/16 in each direction on this parabola. So if the parabola opens like so, the focus would be on the inside of the parabola and the directrix would be on the out. This is a very rough sketch, obviously, and not to scale either. The directrix would be on the outside of the parabola. The focus would be on the inside of the parabola. So the ordered pair for the focus would then be -5 and 15/16, -1. And then the directrix would be x equals -6 and 1/16. You could change that to an improper fraction if you prefer, but that's totally fine just like that. So again, we could have determined way back here that that was a parabola and you didn't necessarily have to do all of that work, but all that work is there for you to refresh your memory on what it looks like when we're working with parabolas. Horizontal parabolas are a little more complicated than vertical. Okay, so I'm going to go ahead and erase, and then we'll do, I have 2 more examples. Okay, So what I talked about with the circle is whenever it's an x squared or a y squared, it's either a circle, an ellipse, or a hyperbola. Circles and ellipses are addition, so x squared plus y squared. Hyperbolas have a subtraction in between the two fractions. So if you look back at our, I don't know how to do it. Here it is. So here, hyperbolas have subtraction in between the two fractions. Ellipses have addition between the two fractions, and then circles have addition in between the two sets of parentheses. So this is a hyperbola, I can tell, because it's subtraction in between. And so then what I'm going to do, it needs to be equal to 1. So I'm going to move the 225 to the right-hand side. And then I want something that looks like this, right? I want a y squared over a number minus an x squared over a number equals to 1. So how do I get it equal to 1? Well, I divide everything by 225. So I divide the 225 on the right-hand side and I get 1. I divide the 9 by 225 and I divide the 25 by 225. And then I simplify those fractions. So not 225 divided by 9 simplifies, or no, 25 over 225. Let me just talk. Simplifies to 9, 1/9. And then this would simplify to 1/25. And so that would be your final in standard form of a hyperbola. And again, I can tell way back here that it's not a circle because it has coefficients in front of the x squared and y squared. And I can tell that it is not an ellipse because there's subtraction instead of addition between the two. And so therefore it's a hyperbola. Hyperbolas have subtraction in between. So I'm going to go ahead and erase, and then I have one last example, and you could probably guess it's going to be an ellipse. Okay, so similar to what we did with the parabola, I'm going to pair up this stuff, or I did this with a circle as well, I guess. I'm going to pair up the stuff that the x's together, the y's together, and I'm going to move the 71 to the right side. And then I'm going to look at just the 9x squared 18x, just the 16y squared 64y, and I'm going to factor out the leading coefficient. So the 9 in this case factors out, and I'm left with x squared minus 2x, and then I'm going to add that number in there that completes the square. Same thing here, I'm going to factor out the 16, leaving me with y squared plus 4y, and then I'm going to add my number that completes a square. So half of 2 is 1, 1 squared is 1. And then this 1 is actually a 9, right? The 9 in front multiplies. So 1 times 9, I'm going to add a 9 to the right side of the equation. And then half of 4 is 2, and 2 squared is 4. And then 4 times 16 is 64. So I'm adding 64 to the right side of the equation. So then this looks like 9x minus 1 squared. 16y plus 2, so that's fancy, squared equal, and then whatever 71 plus 9 plus 64 is 144. Okay, so now that's very similar to what we did with the circle and the parabola. And now we're going to do what we did with the hyperbola. So we're going to take this, we need it to equal 1, right? We want this sort of a picture. Right, that's what the standard form of an ellipse looks like. This would be y plus 2 right here. And we want it to equal 1. Sorry, that's a plus in the middle. And so in order to get it equal 1, I'm going to divide everything by 144. And again, I want the x minus 1 to remain. I want the y plus 2 to remain. I just want to simplify the fraction the 9 over the 144, and the 16 over the 144. And when those simplify, 144, 9 simplifies to 1/16, and then 16 and 144 simplifies to 1/9, like so. And so then this center would be at 1, -2, right? And then we know that A is bigger on an ellipse, so A is 4, and B is 3. Sorry, that doesn't look like a B. And then you could calculate your C, A squared. It's A squared equals B squared plus C squared. So I would calculate my C. And then to graph my ellipse, you would do your center at 1, -2. And then you would count in the X direction, you would go 4 to the right and 4 to the left. And then you would put your two major axis endpoints there, vertices, and then you would count 3 up and 3 down. And those are your two minor axis endpoints, your co-vertices. And then remember that your foci, that's ugly. It's a very rough sketch, guys. And then remember that your foci would be inside in here, just inside on the major axis. You would have your focal points, and your focal points in this case, C is the square root of 7. So I would take 1 plus the square root of 7 to get to the focal point on the right, and 1 minus the square root of 7 to get to the focal point on the left. Okay, so take a look at the Pearson online activity or assignment that I posted. It's very short, like 5 questions, not super difficult. And let me know if you have any questions.